On this part of the video, we'll be looking at question 1 and question 2 of paper 2, which is statistics. We'll start off with the UKZN 2020 trial exam. So here we have question 1 of that exam paper. We look at the total number of red cards issued per country to players during a soccer competition. So here we are given the number of red cards and an interval. So you either have 0 red cards, 1 red card, or 2 red cards. And countries with either 0, 1, or 2 red cards are 27. And countries with red cards between 2 and 4 are 15. And countries with red cards between 4 and 6 are 5. And countries with red cards between 6 and 8 are 5. And countries with red cards between 8 and 10 are 3. So we have our frequency. For number 1, we are required to estimate the mean of the number of red cards per country. The mean is sometimes denoted as X bar, which is the sum of the FIs times the XIs divided by the sum of the FIs, where the sum of the FIs is just the total number of red cards, where the sum of the FIs is the total number of red cards, and the XIs are just the midpoints of the interval. So we need to find the sum of the product between FIs times XIs. Before you do that, we need to find the XIs, which are the midpoint of the interval. To find the midpoint of the interval, we'll take the upper limit plus the lower limit divided by 2. That is, we'll denote x1 as 2 plus 0 divided by 2, which is equal to 1. And x2 will be 4 plus 2 divided by 2. So it is 4 plus 2 divided by 2, which is 6, divided by 2, which is 3. And x3 is 6 plus 4 divided by 2. 6 plus 4 divided by 2, which is 10, divided by 2, which is 5. And x4 will be equal to 8 plus 6 divided by 2, which is equal to 14 divided by 2, which is 7. And x5 will be equal to 10 plus 8 divided by 2, which is 18 divided by 2, and this is 9. And these are our midpoints. So our midpoints are 2 plus 0 divided by 2, which is 1. 4 plus 2 divided by 2, which is 3. 6 plus 4 divided by 2, which is 5. 1, 3, 5. 8 plus 6 divided by 2, which is 7. 8 plus 10 divided by 2, which is 9. So we have our frequency. Now we need the product of the two. to get f times x. So we multiply 27 times 1, we get 27. If we multiply 15 if we multiply 15 by 3, we get 45. If we multiply 5 by 5, we get 25. If we multiply 5 by 7, we get 35. If we multiply 3 by 9, we get 27. So what you want to do is, we want to sum all the f times xi. To get the numerator, we need to add all the fi times xi. So adding all these values, we get 159. We also need to add all the frequencies. To get the total number of red cards, we need to add all the frequencies. Adding all these values, we should get 55. Our interests are in these two values, which is the sum of all the fi times xi and the sum of all the fi's to get the mean. So the mean in our case would be equal to the sum of all the fi times xi, which is 159, divided by the total number of red cards, which is 55. And simplifying, we have 159 divided by 55, we get 2.89. 2.89, which is our mean. So the mean is 2.89. To find the mean, we need the sum of all the fi's times xi divided by the sum of the frequencies. And we got 159 divided by 55, which is 2.89. We are also required to find the ogive curve representing the data. To draw an ogive, we need what is known as a cumulative frequency. To find the cumulative frequency, all we need to do is we should take the first value and write it on the right hand side. So our first value is equal to 27. And what we want to do is we want to add 27 with the next value, which is 15. That is the value between 2 and 4, which is 15. The number of red cards between 2 and 4 is 15, so we add 27 with 15. We get 42. We add 42 with 5, we're adding 42 with 5, we get 47. We add 47 with 5, we get 52. We add 52 with 3, we get 55. To check if your addition is correct, the final value should always be the total number of red cards. In this case, the final value should always be the total. Your final value should always equals the total. If that is the case, then your addition must have been correct. This is known as cumulative frequency. Now, to draw an ogive, we need the cumulative frequency and we need the upper limit. On our cumulative frequency, what we'll do is we have at x equal to 2, the y value or cumulative frequency is 27. When x is equal to 4, the y value or the cumulative frequency is equal to 42. When x is equal to 6, the cumulative frequency is equal to 47. When x is equal to 8, the cumulative frequency is 52. And when x is equal to 10, the cumulative frequency is equal to 55. And here I've already sketched my ogive. Here's a sketch of my ogive. And when x is 0, the frequency is 0. When x is 2, my frequency is when x is 2, our frequency is 27. When x is 2, our frequency is 27. So I'll draw a dot slightly below the line y is equal to 30, which is 57. When x is 4, our frequency is 42. When x is 4, our frequency is 42. So here our dot should be slightly above 40. And when x is 6, our frequency is 47, so it should be slightly below 50. When x is 8, our frequency is 52, which is slightly above 50. When x is 10, our frequency is 55. And this is my ogive curve. So we just need to connect the dots. We're also required to calculate the interquartile range of the number of red cards. Now, to find the interquartile range, your interquartile range is equal to Q3, which is your third quartile or 75th percentile, minus a Q1, which is your first quartile or the 25th percentile. So it is Q3 minus Q1. That will give us our interquartile range. So we need to find Q1 and Q3 using the ogive curve. Now, from the ogive curve, to find Q1, we take the number of red cards. To find Q1, we take the number of red cards, which is 55, and we divide by 4, since it is a quarter. We multiply by quarter. And simplifying, we have 55 divided by 4, which is 13.75. What this means is that the first quartile is in the approximately the 14th position. So this is the position of the first quartile. So looking at the Y values, 13.75 should be somewhere around this position. So here, slightly above 10. So what you do is you draw a horizontal line going touching the ogive curve, and we draw a vertical line downwards, and read the value and the x value, and our x value should be equal to 1. Recall that with red cards we either have 0 red card or 1 red card or 2 red cards. Therefore Q1, the first quartile, is equal to 1. We do the same thing for Q3. We look for the position of Q3. The position of Q3 will be equal to 3 divided by 4, which is 0.75, multiplied by 55, which is the total frequency or the number of red cards. So we have 55 times 3 divided by 4, and there we get 41.25, which is the position of the dead quartile. So the dead quartile is positioned at 41.25. Again, we read on the y-axis, your 41.25 should be just slightly above 40. Should be just slightly above 40. So we draw a line, horizontal line, straight to our curve, and we drop the line vertically. And this implies that the dead quartile is equal to 4. Again, the number of red cards and this interval are either 2, 3, or 4. So our dead quartile must be 4. This implies that Q3 is equal to 4. We are looking for the interquartile range. For the interquartile range would be equal to dead quartile minus the first quartile. And this is equal to 4 minus 1, which is equal to 3. It is the dead quartile minus the first quartile, which is 4 minus 1, and this is equal to 3. Now, moving on to question 2 of the 2020 KZN trial paper. For question 2, we have a table which shows a relationship between the monthly rent a person pays for an apartment and the person's monthly income, which is the Y values. And these are given. Here we want to find the equation of the regression line. So we want to use this data to find the equation of the regression line. Now, to find the equation of the regression line, all we need to do is we need to capture the data into our calculator. Here I'm using a KSL calculator. The first thing you need to do with your calculator is set it up to state mode. To set it up to step mode, you go to mode, which is right next to the on button of your calculator. So you go to mode. With mode, you choose number 2, which says state. And after choosing number 2, which says stats, you go to number 2, which says A plus B times X, which is your regression line. Your regression line is the line Y estimate equals A plus B times X. So you choose number 2. With number 2, there you should enter your data, starting off with the X values, which are your rent in this case. So we should enter the data in the calculator. So we have 2, and we have 3, and we have 3.5, we have 5.2, we have 5.6, and we have 6. And those are our X values. And for the Y values, we have 9, we have 13.3, 13.5, we have 15, and we have 16.5, we have 17, and we have 20. Now, to find the regression line, once we have entered the data, we need to press AC, and thereafter we need to press Shift, and then press number 1. After pressing number 1, which says stats, we choose regression or REG. In my case, REG is located at number 5. We choose number 5. With number 5, you have A as number 1, B as number 2, R as number 3, X as number 4, and Y is number 5. So we're looking for the A value of the regression line. And the A value in my case, which is located at number 1, we press 1, we then press equals, we get the A value. So the A value for this data, we should get 5.97. And for the B value, we get B equal to, which is number 2 of your calculator. The B value is equal to 2.18. We therefore have Y estimate is equal to 5.97 plus 2.18 times X, which is the equation of the regression line. Number 2, we want to estimate the monthly income if the rent per month is equal to 9,000. So we want to estimate monthly income if rent per month is equal to 9,000. Now notice that our values are in 1 unit and this has 3 units. This is simply because these values are in thousands of rands. Since these values are in thousands of rands, we need to divide the 9,000 by 1,000. And dividing the 9,000 by 1,000, we get 9 to convert to thousands of rands. So we should use 9 in our regression line to estimate the monthly income. So we have y estimate is equal to 5.97 plus 2.18 times 9. And this gives us a 25.59. So y estimate is 25.59, but we want to estimate the monthly income. Since we are estimating the monthly income, we need to multiply the y estimate by 1000, and multiplying the y estimate by 1000, we get the monthly income. In rands, it should be 2558,89. So the monthly income estimate is 2,558.89 cents. We also want to find the correlation coefficients. To find the correlation coefficients, again we go to Shift, we press 1, we choose 5 for a cursor, or we choose REG. And after choosing REG, you look for R, which is the correlation coefficient. And for the cursor calculator, that value, you should press number 3. After pressing number 3, you should press equal, then you should get the regression coefficients. In my case, the regression coefficients is 0.94. So I get 0.94 for the regression coefficients, which is R on your calculator, small letter R. And for 2.4, we want to describe the relationship between the monthly rent income, the monthly rent and the monthly income. So we want to find the relationship between these two values, the X and the Y value. Now, since R is very close to 1, since R is very close to 1, since R equals 0.94 is very close to 1, that implies that there is a strong positive relationship between rent, monthly rent and monthly income. So there's a strong positive relationship between monthly rent and monthly income, since R is very close to 1. So for these questions, you need to use the word strong, you need to use the word positive if R is very close to 1, and it is positive in this case. So that is the relationship between monthly rent and monthly income. Now moving on to Limpopo. Here, this question was taken from the Limpopo 2020 trial exam. Again, we look at question 1 and 2, statistics. For this question, we have two schools A and B in the Lephalale circuit are in competition. So we have two schools that are in competition. They want to see which one of them performs best in mathematics during the June examination. Both schools have 25 learners. We have 25 learners for both schools. We want to highlight the 25 because that's the number of the population we are working with, which is 25. The 5-number summary for the school A. So we have a 5-number summary for school A, which is 9, 23,5, 55, 75, and 91. The box whisker diagram for learners in B is given. So we're given a box whisker plot for learners in B. We are required to draw the box and whisker diagram which represents the marks of school A on the grid in your answer book, clearly indicating all relevant values. So we want to sketch a box. Whisker diagram. Now to sketch the box whisker diagram, we need to use the 5-number summary. What this 5-number summary tells us is that your first value is the minimum value. So it's the smallest value. And the last value is the maximum value, which is the largest value. And the second value is your first quartile. And this value is your median, and we have the third quartile. So we have Q1, Q2, and Q3. So we have the first value, which is 9. I'm trying to compare this with the above box whisker plot. And the first quartile is 23.5. Which is slightly less than this. So here we have 23.5. Your second quartile is 55. And your third quartile is 75. And your maximum is at 91. So this is our box whisker plot. With the minimum being equal to 9, the first quartile is 23.5, the second quartile is 55, the third quartile is 75, and the max is 91. For the second question, we are required to determine which school performed better in the junior examination and give reasons. So we're comparing these two box whisker plots. Now, when comparing these two, if we look at the first quartile, look at the first quartile for Q1, which is the lower 25th percentile of students. You can clearly see that from school A, only with if we take the total number of students, which is 25, and multiply by 2.5, we get 6.25 learners. So that implies that about 7 learners got less than 23.5, and in school A, 7 learners got less than 30, implying B is performing better. So 75% of students in B, let's write this one. 75% of students of learners in school A got more than 23.5%, while 75% of learners in school B got 30% and more. So 30% and more. Therefore, school B performed better than school A. So B performed better based on the 75 percentile of students. Just look at the lower 25% students. Even if we look at the median, that is the 50% of the students, look at 50% percentile of the students, you can clearly see that with school B, the upper 50% got 60 and more, 60% and more, while in school A, the upper 50% got only 55 and more. So again, B is performing better than A, comparing the upper 50%. So you can either compare the upper 50% of the students or the upper 75% or lower 75% of the students. Now look at number 1.2. We have learners at Bahananwa High School who travel from 3 villages A, B, and C. The table below shows the number of learners from each village and their mean travel time from home to school. So we have village A, B, and C, and we are given the number of learners in A, which is 135, and the number of learners in B, which is 225, and the learners in C, which is 200. We are given the mean travel time in meters. For A, this is 24, for B, this is 32, and for C, it is X. The mean travel time for learners living in village C is the same as the mean travel time for all 55 learners. We want to find the mean travel time for the learners from village C. We have the mean and we have the number of learners, mean number of learners, and we have the mean and the number of learners. Recall that the mean X bar is equal to sum of the sum of the Fi times the Xi divided by n. Or the sum of all the Xi divided by n. This then implies that n times X bar is equal to the sum of all the Fi's times the Xi. We're looking for the sum, the total sum of all the Fi times the Xi. So for A, I'll have the sum of the Fi times the Xi, and for B, I'll have the sum of the Fi times the Xi, and for C, I want to find the sum of the Fi times the Xi, and I want to add all of those. And that can be done by simply multiplying n times X bar. Since n times X bar is equal to the sum of all the Fi times the Xi. So starting with A, if I'm summing, so I'll say n, which is 185, multiplied by X bar, which is 24, plus n 225 times X bar, which is 32, plus n, which is 200 times X bar. In this case, it is X. And what we want to do is we want to divide this by the total number of learners. And the total number of learners is given. It is equal to 560. And this will give us the total X bar, total mean, the mean for all learners. This will give us the mean for all learners. And we are told that the mean for all learners is the same as the mean for learners in C is the same as the mean for all learners. So this is the mean for all learners, and this is the mean for learners in C. So this should be equal to X. So the mean for all learners is equal to the mean for C. We have one equation and one unknown, so we should be able to solve for X. Simplifying, we have 135 times 24 plus 225 times 32, and that gives us 10,440 plus 200x is equal to 560x. If we multiply both sides by 560, we multiply both sides by 550 to get the 560, we get the 560x. And what is on the left is just the numerator. So I've added these two values to get the 10440, and I'm also adding this 200x. Grouping like terms, I'll take the 200x to the right, so we have 10,440 is equal to 560 minus 200 is 360x. Therefore, x should be equal to 10,440 divided by 360. And this is equal to 29. So the mean travel time for learners in C is equal to 29. And travel time for learners in C is equal to 29. This example is taken from the November 2019 exam paper. Option number 2. We have a survey which was conducted among hundreds of people. So here the number of people is hundreds. About the amounts that they pay on a monthly basis for their cell phone contracts. The person carrying out the survey calculated the estimated mean to be 309 per month. So we have the mean, which is 309 per month. Unfortunately, he lost some of the data thereafter. The partial results of the survey are shown in the frequency table. So here we have partial results with some missing data. And the first question is, how many people paid 200 or less on their monthly cell phone contracts? So we look for people who paid 200 and less. Between 0 and 100, people who paid between 0 and 100 are 7, and people who paid between 100 and 200 are 12. So those who have paid less than 200 are 12 plus 7. So we have 12 plus 7 people have paid less than 200, which is equal to 19. So we have 19 people have paid less than 200. You know, when I use the information above to show that the value of A is 24 and the value of B is 16. Now, we know that the sum of the frequency is equal to the total number of people. That is, we know that the sum of the frequency, we know that 7 plus 12 plus A plus 35 plus B plus C 6 is equal to 100. So if we sum the frequency, we should get the number of people. So if we add 7, 12, 35, and 6, we get 60 plus A plus B is equal to 100, which implies that A plus B is equal to 100 minus 60, which is equal to 40. You can call that equation 1. We are also given that the mean is equal to 309. So we need to find the mean for this data. To find the mean, recall that the mean x bar is equal to the sum of the fi times xi divided by n, where n is the population size, or divided by the sum of the frequencies, which is n. So we need to find xi. Xi is, recall that the xi's are the midpoint. So we just look for the midpoints of these intervals. To find the midpoint, we take 100 divided by 100 plus 0 divided by 2 to get 50. If we take 100 plus 300 divided by 2, we have 300 divided by 2, which is equal to 150. 200 plus 300 is 500 divided by 2 is equal to 250. 300 plus 400 is 700 divided by 2 is 350. 400 plus 500 is 900 divided by 2 is equal to 450. 500 plus 600 is 1100 divided by 2 is 550. And these are our xi, which are the midpoints of the interval. And we're looking for the sum of the fi times the xi. We're looking for the sum of the xi times the fi. So we're multiplying these two values and we add it. Multiplying these values and we add it. So we have x bar is equal to the sum of the fi's times the xi's divided by the sum of the fi's. X bar is given, it is 309, and the sum of the fi's is also given, it is equal to 100. You just need the sum of the fi's times the xi. So we have 50 times 7 plus 150 times 12 plus 250 times A plus 350 times 35 plus 450B plus 550 times 6. And this this is all over hundreds, where the sum of the FIs is equal to 100. So if we multiply both sides by hundreds and add the like terms, we have 30900 is equal to, so we're adding these signs. If we take the product and add, we should get 17700 plus 250A plus 450B. You just need to find A and B. You can call this equation so. So we have two equations and two unknowns. We need to solve for A and B. Now from this equation, we can take B to the right hand side or A to the right hand side, and that B is 40 minus B. So what I want to do is in equation 2, I want to replace equation 2 with this value, 40 minus B. So we have 309 minus 17,700. If we subtract those two, we should get 13,200. 13,200 is equal to A which is 250, A plus B 450, 40 minus B. And simplifying, we have 450 times 40, which is equal to 18,000. And we have 250 A minus 450 A. 250A minus 450A is negative 200, so I want to take that to the left hand side. So we have 200A and we have 18,000 minus 13,200 and that is 4,800, which implies that A is equal to 4,800 divided by 2,000, which is equal to 24. So A is equal to 24. Replacing 24 into this equation, B is equal to 40 minus A, we get B. B is equal to 40 minus A, which is equal to 16. Solving our problem. We have A is equal to 24 and B is equal to 16. For number 2.3, we want to write down the model. We want to write down the model class for the date. We look for the model class. The model class is a class with the largest frequency. So here A is 24, B is 16. So the class with the largest frequency is this class, X lying between 300 and 400. So we have 300 X less than or equal to 400 would be our model class. On the grid provided in the answer book, we want to draw an ogive to represent the data. Recall that if we want to draw the ogive, we have to look at the upper class. We're looking at the upper class, and we need the cumulative frequency for the y values. Here we have the x values and we have the y values. So for the y values, we need the cumulative frequency. So this constructs a cumulative frequency table. It would be easier if it's constructed somewhere like there. So we have the lower value or lower frequency, which is 7. So we want to take 7 plus 12. 7 plus 12 is equal to 19. And we take 19, we add 24 to get 43. We take 43, we add 35 to get 78. We take 78, we add 16 to get 94. We take 94, we add 6, we should get the total number of people after adding the last 10. We should get the total. Here we get hundreds. If we are not getting hundreds, then there must be something wrong. We must have done something wrong. We should always get the total at that time. So whenever x is hundreds, y is 7. Whenever x is 200, y is 19. Whenever x is 300, y is 43. Whenever x is 400, y is 78. Whenever x is 500, y is 94. Whenever x is 600, y is equal to 100. And this is our object. We need to just sketch at this point, and these are the x values, and these are the y values. I've already sketched the ogive. So here we have our ogive. Whenever x is 100, y is 7, which is slightly less than 10. Whenever x is 200, y is 19, and slightly below 20. Whenever y is 300, sorry, x is 300, y is x equal to 300, y is 43, 28, 94. 43, 78, 94, and then here we have 100. So this is our ogive curve. For this session, we'll be looking at question number 3 and 4 of paper 2. Number 3 and 4 is usually analytical geometry. This paper is taken from the 2016 UKZN paper. Then the diagram below, PQRS is a parallelogram. The vertices P and S lie on the y-axis. The side QR is produced to its own length to T. QR is equal to RT. The point Q, which is 35, and point S, with x equal to 0 and y equal to 2, and the length of PS is equal to 2 units. The line segment PT intersect SR at W. PW is equal to WT. So PW is equal to WT. We are required to determine the coordinates of the following points: point P, point R, point C, and point W. Now, we are given that PS is equal to 2 units. That is, the distance from P to S is 2 units. So this distance is 2 units. That is given. So to find P, all you need to do is add the distance OS and the distance SP. That will give us the coordinates of P. So the coordinates of P, we just need to add the distance from 0 to 2, which is 2 units, and the length of PS, which is 2 units, to get 4. So if we add these two, we get the coordinates of P. P is the point when x is 0 and y will be equal to 2 plus 2, which is 4. This is 1.1.1. Now for 1.1.2, we're looking for R. Now we're given that PQRS is a parallelogram. That implies that PO is parallel to QT. If that is the case, if these two lines are parallel, that implies that the x value of R is the same as the Q value of the x value of Q. The x value of R should be the same as the x value of Q. This is a vertical line which is parallel to the y-axis. So for Q, we have the x value which is 3 units. So we're just looking for the y value. Now to find the y value, we know that PS is equal to 2 units. Again, for the same reason, since this is a parallelogram, QR should also be 2 units. If QR is 2 units, then the y value of R is the y value of Q minus 2. The y value of R would be the y value of Q minus 2. So it is 5 minus 2, which is equal to 3. Since the distance from this point to this point is 2 units. So to get this length, all you need to do is take the 5 units length minus the 2 units. That will give us the distance from the x-axis to r, which is 3. And for 1.1.3, we are required to find a t. That is the coordinates of t. Again, since this line qt is parallel to PO, the x value of t should be exactly the same as the x value of r, which should be exactly the same as the x value of q. So the x value of t should also be 3. So we just need to find the y value of t. Now qr, we said was 2 units, and rt is the same as qr, so it should also be 2 units. So to find the y value of t, we need to take these two values, 2 plus 2. If we add them and subtract 5, we should have the remaining piece. So the y value of t will be equal to 5 minus 2 minus 2. 5 minus 2 minus 2 is equal to 1. So the y value of t, we know that these two sides are equal. So we're adding 2 plus 2, and it's taking 5 minus 2 plus 2, which is equal to 1. And for 1.1.4, we're looking for the coordinates of w. We know the coordinates of p, and we know the coordinates of t. We have the coordinates of p, we have the coordinates of t. W is halfway between p and t. So we can use the midpoint theorem in order to find the coordinates of t. So we'll take the average of x. So we have from p, we have x equal to 0. And from t, we have x equal to 3. And we want to divide this by 2. And with the y values, with p, we have y equal to 4. And with t, we have y equal to 1. We're adding these 2 and dividing by 2. So the coordinate of a w will be 3 over 2 and 5 over 2. Here we've used the midpoint theorem. It is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. For number 1.2, we are required to calculate the gradient of PQ. We want to find the gradient of PQ. The gradient of PQ would be equal to change in y over change in x. We have p, we have q. We want to find the change in y over change in x. Sorry, this is r, and we have p, we have q. We want to find a change in y over change in x. And so we have 5 minus 4 divided by 3 minus 0. Is the change in y over change in x using p and q. And this is equal to 1 divided by 2. So the gradient of PQ is equal to 1 over 2. Change in y over change in x. Want to find the equation of the line PQ. Want to find the equation of the line PQ. So for 1.2.2, want to find the equation of the line PQ. Now the equation of the line is given by the equation y is equal to mx plus c, which is the equation of the straight line. Now we have the gradient of PQ m is equal to 1 over 3. So we have y is equal to 1 over 3x plus c. So we just need to find the value c. To find the value c, we can either use the point q or we can use the point p, because they both lie in the line PQ. So I'll choose p, since p is much easier to work with. It is easy to see from p that c is equal to 4. That is, when y is 4, x is equal to 0. Therefore, c should be equal to 4. So the equation of the line PQ is given by that line by the equation y is equal to 1 over 3x plus 4. And lastly, we want to find the length of SQ. The length of SQ. Number 1.3, we want to find the length of SQ. So we need to use the distance formula, since we have 2 points. We have point S, we have point Q, we can use the distance formula. So the length of SQ should be equal to the square root of the change in the x value so we have 3 minus 0 all squared plus the change in the y value, 5 minus 2 all squared. Simplifying, we look for the square root of 9 plus 9. Which is equal to 3 square root 2. So the length of SQ is equal to 3 square root 2 units. So the tools we need to solve these problems are: 1, the distance formula. Distance is equal to the square root of x1 minus x2 whole squared plus y1 minus y2 whole squared. We need the gradients formula. The gradient is equal to change in y over change in x. We need the midpoint theorem. The midpoint we have for the x value, it is x1 plus x2 divided by 2, and for the y value, we look at y1 plus y2 divided by 2. So you need to be familiar with these formulas in order to solve these problems. This is also taken from the same exam. That's question number 2 from the 2016 KZN November paper. So here in the diagram below, C is the center of the cycle with radius equal to 5 units. F and G are the point of the intersection of the circle with y-axis and the x-axis respectively. HK is the tangent to the circle at F and cuts the x-axis at H. We are required to find the equation of the circle. So for 2.1, we want to find the equation of the circle. So circles are normally located at the origin, and the equation are given by x squared plus y squared is equal to r squared. So from that equation, we have x, which is shifted. X is shifted 3 units to the right. Since x is shifted 3 units to the right, we have x minus 3 whole squared plus y, which is also shifted 3 units down. Since y is shifted 3 units down, we should add 3 whole squared, and that should be equal to the radius squared. We're given the radius is equal to 5 units, so this should be equal to 5 squared, which is 25. If we are shifting down, we add. If we are shifting up, we subtract. If we're shifting to the right, we subtract. If we're shifting to the left, we add. For number 2.1.2, want to find the coordinates of F and G. We're looking for the coordinates of F and G. Since F and G lie on the circumference of the circle, we can easily find their values using this equation. So for 2.1.2, if we want to find G is when the Y value is 0. G is located when the Y value is 0 of the circle. So we have x minus 3 all squared plus 0 plus 3 all squared is equal to 25. And if we simplify, we have x minus 3 all squared is equal to 25 minus 9, where 3 squared is equal to 9. Therefore, x minus 3 all squared is equal to 16. If we take the square root of both sides, we have x minus 3 is equal to plus minus 4. So x minus 3 can either be positive 4 or it can be negative 4. If x minus 3 is positive 4, then we have x equal to 4 plus 3, which is 7. If x minus 3 is negative 4, we have x equal to minus 4 plus 3, which is minus 1. So x is either 7 or minus 1. G is in the first quadrant. Since G is on the first quadrant, G must be the point when x is 7, y is equal to 0. Which implies that the blue point should be the point when x is equal to minus 1, y is equal to 0, which is the second intersection. So we have these 2 points. Either x is here, which is G, or x is in this location, negative quadrants. So we have the coordinates of G. We need to find the coordinates of F. To find the coordinates of F, F is located at a point when x is 0. The x value is 0. So we'll go back to our equation, replace x with 0. So for the equation, we have x equal to 0 minus 3 all squared plus y plus 3 all squared is equal to 25. Since x is 0, we replace x with 0. And we solve for y. So we have y plus 3 all squared is equal to 25 minus 9. Therefore, y plus 3 all squared is equal to 16. Taking the square roots of both sides, we have y plus 3 is equal to plus minus 4. When this value is positive, we get y equal to 4 minus 3, which is equal to 1. When this value is negative, we get y equals minus 4 minus 3, which is minus 7. So y is either equal to 1 or y is equal to minus 7. The negative y values should be at this point. So here we have when x is equal to 0, y is equal to minus 7. And the positive value would be at f. This is the point when x is equal to 0, y is equal to 1. Now for number 2.1.3, we are required to find the equation of the tangent HK. We are required to find the equation of the tangent HK. Now to find the equation of the tangent HK, we need either 2 points on HK or 1 point on HK and a gradient. If HK is a tangent, that implies that the line from F the line from F to C, the line from F to C is perpendicular to HK. The line from F to C is perpendicular to HK. If that is the case, then we just need to find the gradient of FC. The gradient of FC is equal to change in y divided by change in x. We have change in y over change in x using the point F and C. And here you change in y over change in x. Is equal to minus 4 divided by 3. This is the gradient of the line FC. To find the gradient of the line HK, we know that these two are perpendicular. That implies that the gradient of FC times the gradient of HK is equal to minus 1. Therefore, the gradient of HK should be equal to 3 divided by 4. The gradient of HK should be 3 divided by 4, since these two are perpendicular. So we have the gradient of HK. We can find the equation of HK. The equation HK is given by the equation y is equal to mx plus c, where m is 3 over 4. So it's the line y is equal to 3 over 4x plus c. We just need to find c. To find c, we can use the point F, which is on the line HK. The point F is the point when x is 0, y is equal to 1. Therefore, c must be 1. 1 is equal to 3 over 4 times 0 plus c, implying that c is equal to 1. So our equation should be y is equal to 3 over 4x plus 1. Which is the equation of the tangent line. And for number 2.2, we are given a diagram with a circle center P, which has a radius of 2 units and touches the x and the y axis. The circle with the center Q touches the circle with the center P externally at R. Want to find the equation of the circle with center Q. So we want to find the equation of this circle. To find the equation of this circle, we need to find the radius of this circle. And to find the radius of this circle, we just need to find the length of this line. If we can find the length of this line, then the radius of the circle will be the radius of this the length of this line minus the radius of the circle centered at P. Then you should have the radius of the circle centered at Q. So we're looking for length PQ and length PQ is the square root of x1 minus x2 all squared plus y1 minus y2 all squared. Simplifying, we are actually looking for the square root of 4 squared, which is 16, plus 9 squared, 3 squared, which is 9. This is the square root of 25, which is equal to 5. So the length PQ is equal to 5. So what I want to do is I want to remove from PQ, we want to remove this line. We want to remove this line. This line is 2 units. This line is 2 units. So what we want to do is we want to remove this 2 units. So we have the radius for the circle centered at Q should be equal to 5 minus 2, which is equal to 3. So the radius for the circle centered at Q should be equal to 3 units. The equation of a circle is given by the equation x squared plus y squared is equal to r squared if it's centered at the origin. So all we're doing is either shifting it up, down, left, or right. In this case, we're shifting it right and up. So we're shifting x to the right. If we're shifting to the right, we subtract. So it is x minus 6 all squared plus we're shifting y up. If we're shifting up, we subtract. And we square. And this is equal to r squared. Where r squared is 3. Where r is equal to 3. So the equation should be x minus 6 all squared plus y minus 5 all squared is equal to 9. We can leave it in this format unless otherwise stated. The following example is taken from the 2020 UKZN tribes. So for this example, we have KLMN, which is a quadrilateral, with K 410, L11, M 40, and N 82. And we want to find the gradient of LM and the gradient of MN. So we want to find the gradients of these two lines. Let's start off with the gradients of LM. So we are looking for the gradient of LM. this is equal to change in y. So it is 1 minus 0 divided by change in x, which is 1 minus 4. And this should be negative 1 over 3. And for the gradient of ML, MN, the gradient of MN, again, we're looking for a change in y. 2 minus 0 divided by change in x, 8 minus 4. And this is equal to 2 divided by 4, which is equal to 1 divided by 2. It's a change in y over change in x. Change in y over change in x. You get the gradients of MM and the gradients of MN. For number 3.1.2, we're looking for the length of KM. Length of KM. Now notice that with KM, they both have the same x value. The x value for K is 4 and the x value for M is equal to 4. And M is located at the x-axis. Therefore, the length of Km is just 7. It is just 10 units, but let's use the distance formula. The length of a Km is equal to the square root of x1 minus x2 all squared plus y1 minus y2 all squared. So this is equal to the square root of 10 squared, which is equal to 10, as we expected. So the length of Km is 10. For 3.1.3, want to find the value of theta. We want to find the value of theta. This is the angle of inclination, therefore tan theta should be equal to the gradient of Mn. Tan theta should be equal to the gradient of Mn, where the gradient of Mn is equal to half. Gradient Mn is equal to half. Therefore, tan theta should be equal to half. And to find theta is just arctan of half. And arctan of half is equal to 26.5 7 degrees, which is 26.57 degrees. And for number 3.1.4, we're looking for the midpoint of ln. We're looking for the midpoint of ln, so we just need to use the midpoint theorem. The midpoint of ln would be given by the average x value, so we have 1 plus 8 divided by 2. And for the y value, we're looking for 2 plus 1 divided by 2. Two plus 1 divided by 2. So the midpoint is the point 9/2 and 3/2. And for number 3.2, we want to show that KL is perpendicular to LM. We want to show that these two lines are perpendicular to each other. So we need the gradient of LK and the gradient of LM. We already have the gradient for LM, which is -1/3. For these two to be perpendicular, then the gradient of LK should be equal to 3. So we just need to show that the gradient of LK is equal to 3. Then these two lines will be perpendicular. So we're looking for the gradient of LK. And this is equal to change in Y (10 minus 1) divided by change in X. Change in X is 4 minus 1. And this is equal to 9 divided by 3, which is equal to 3 as expected. If this value is 3, you can clearly see that the gradient of LK times the gradient of LM which is equal to 3 times negative 1 over 3, which is equal to minus 1. Since the product of the two gradients is equal to minus 1, therefore the two lines are perpendicular. And therefore LK is perpendicular to LM, since the product of the gradients is equal to 1. We also want to prove that KLMN is a cyclic quad. We want to prove that KLMN is a cyclic quad. So we want to prove that this is a cyclic quad. We know that KL is perpendicular to LM. If KL is perpendicular to ML, that implies that the interior angle is 90 degrees. That implies that here we have a 90 degrees. So if we can show that this is also 90 degrees, we are done. We can use interior angles of a cyclic quad. The interior angles of a cyclic quad add up to 180 degrees. That is the opposite angles. So we just need to prove that Kn is perpendicular to Mn. If we can prove that Kn is perpendicular to Mn, then this should be 90 degrees. Now the gradients of Mn we already have. The gradient of Mn is equal to half. So we just need to show that the gradient of Nk is equal to minus 2. We just need to show that the gradient of Nk is equal to minus 2. Let's go ahead and find the gradient of Nk. So we're looking for the gradient of Nk. This is a change in Y so we have 10 we we have 10 minus 2 and 4 minus 8. Change in y. Over change in x. So here we have 8 divided by minus 4, which is equal to minus 2, as expected. So the gradient of Km is minus 2. You can clearly see that the gradient of Nk multiplied by the gradient of Mn is equal to minus 2 times half, which is equal to minus 1. Therefore, Nk is perpendicular to Mn. Therefore, these two lines are perpendicular. Hence, the angle MLK is equal to MNK, which is equal to 90 degrees. So if we add them, plus MNK is equal to 180 degrees. Therefore, we have a cyclic quad. These are interior angles of a cyclic quad. Equal to 180 degrees. This is where we'll stop. Our next session will be on question number 4 and 5. 4 is trigonometry and 5 is Euclidean geometry.